All right, so for today's lesson, we are going to move on to lesson 4.9. And I know it might be some of a jump because we just talked about 4.1.4.2, but 4.9 is still graphing, so I sort of, jumped to the end of the chapter here. Problem of the day is here. List the 5 steps to graphing a quadratic equation standard form. And I'd like you to take a minute, and if you need help, look back to assignment 1 or in 4.1 to see those 5 steps we used. Because today we're going to graph in standard form again, so it's a little bit more of a review. All right, so in our lesson today, 4.9, graph and solve quadratic inequalities, we're going to take a look at, instead of equations, we're going to add an extra step. So take what we did in 4.1 and modify it to do inequalities instead of equations. So what does that mean? All right, so we're going to replace the equal sign with an inequality. So quadratic inequality in 2 variables. We have a less than, greater than, less than or equal to, greater than or equal to. Now, what are the steps to actually graphing them? Step 1, graph the parabola. A dashed line is a less than or greater than. A solid line is less than or equal to or greater than or equal to. So you have to go back to how we graphed standard functions, standard quadratics, to be able to do that. So we're requiring prior knowledge from 4.1. What's new? That it's dashed or solid. Next, we need to determine where we shade. So it's going to be, you're going to test a point in x, y not on the parabola, such as 0, 0. 0, 0 is the one we usually use unless it's on the graph. And the third step, shade the region which makes the inequality true. It's going to be either inside or outside the parabola. So pretty much now we're combining. You've done inequalities in general about 4 times already since the beginning of the year. Our 5th time now is going to be parabolas or quadratic inequalities. So we're sort of piecing together what we did in 4.1 and recalling how we graphed inequalities over the past year so far. All right, so example 1, graph y greater than negative x squared. It's in standard form, so the first thing I'm actually going to do is actually label a, b, and c. A is negative 1, b is 0, so is c. And we know that from the a is in front of x squared, b is in front of x, and c is a constant by itself. All right, so if we refer back to lesson 4.1, the first thing was, does it open up or down? A is negative 1. Negative 1 means it opens down. Now following along, step 2, we're going to do the vertex. And if you recall back in 4.1, we had to use the formula x equals negative b divided by 2a. Hope you're okay with me writing it sideways like this. So we take our negative b, so it's negative 0, divided by 2 times negative 1. When we evaluate it, we're going to get 0. So the x of the vertex is 0. Well, once we get x, we need to find y as well, right? Because it's an ordered pair. So think back to how we found y to recall. Why we plug in x into the original and see what y is. You can notice in the step, I change it from a greater than to an inequality, purely for the fact that I'm evaluating and I don't want it to get a little confusing. We'll take care of the inequality in a little bit here. You see we get 0 as well. So my vertex is 0, 0. So our first plan of action is to plot 0, 0, just here. Don't forget with the vertex, we draw that vertical dashed line through it, because that's our line of symmetry here. All right, so what do we do next? Step 3 was to find the y-intercept. Y-intercept, if you remember back, is your c. And we find out our c is 0. So what we would normally do is we'd move up or down the y-axis to plot it. If we go to plot c, which is 0, what do you notice? You notice that it's on the origin. And what do you also notice? It's the same point that's the vertex. So when these two are the same, all right, that's when we need step 4, which is the table. So step 4 doesn't always come into play. This time it does because the 2 points are the same. I can't draw a symmetric point when they're both the same point there. So what I'm going to do for this one is you need to pick 2 points. I like to pick x, one to the left of the dotted line, one to the right. So let's do -1 and 1. And here's my little table. Let's try to draw a line here. All right, so if I plug in, remember, it goes back into the original to plug in. If I plug them in, you should get the same thing because they're symmetric. You should get -1 for y for both of them. So remember with the table, like we've done before, once again, we take -1 for x and we plug it into the original. All right, so -1 is here. 1, -1 is here. And now we're going to connect it. Now, if you remember back, it said in order to take care of the inequality, we have to do a solid or dashed line. If we go back to the original, it's not or equal to. So we have dashed parabola. So let's try to make it dashed all the way to the end. Like so. All right. Now, instead of step 5, where we talk about max or min, what we're going to add here is we're going to test a point. Because really there's, with max and min, if you're shading an area, you can't really say max or min to it. So I'm going to test a point. I'm going to test, for my point, 1, 1. That's just easier. Remember, I can't use 0, 0. Why? Because 0, 0 is part of the graph. So if I test it, you should get this. 1 greater than -1 squared. One greater than -1. Now if I test, is 1 greater than -1? Yep, it is. So where was our point 1, 1 located? It's here. So here's where it's different. We're going to do inside or outside the parabola. Where's 1, 1 located? Out here. So if it's true, we shade here. If it's false, we shade the inside. It's true. So I want you to shade everything outside here. That's our problem. So let's try another one. Once again, we're going to do the same thing again. Label your A, B, and C. Step 1, you should know it opens up because A is a +1. 2, we're going to do the vertex. And it might not be a bad idea if you are getting the hang of it to actually stop the video and see what you get and then compare with me. Just to see if you're getting it right, because really it's a review of what we've been doing. And honestly, what I like about this lesson though is that I know 4.1 was a very hard lesson, and the nice thing about it is it makes you go over 4.1 to sort of wrap it up, I think, to get a little bit of a better understanding. So here my vertex is 0, -4. Don't forget when you do your vertex to draw a dotted line through the vertex. It's our axis of symmetry. Next step, find your y-intercept. It's -4. -4, remember, y-intercept means up or down. I go up or down, -4 is down 4, and lo and behold, what do you notice again? We're going to need to make a table again, because once again, -4 for the y-intercept and vertex are exactly the same. So let's do a table. And once again, I'm going to use -1 and 1 I like to do 1 point to the left and 1 point to the right. Remember, you plug -1 back into the original. You should get -3 for both y's. So we're just simply evaluating like we've done before. And now we're going to plot those points. And connect them. Now we take a look, greater than or equal to means it's a solid line. So let's connect that here. And I like to go all the way to the top of the grid, or the graph. I mean, in the homework you'll see that you have that option because you want to be able to see is the shading going to be inside or outside. Now step 5 once again is not max or min. 5 we're going to test a point. And actually, in this case, I like to use 0, 0 just because mathematically it's the easiest. And if you see, I could actually use 0, 0 this time. If 0, 0 is true, so let's plot that point here. If 0, 0 is true, I'm going to shade inside. If it's false, I shade outside. So let's see what we get here. Plug it back into the original inequality. I get 0 greater than or equal to -4, which is true. So I shade where 0, 0 lies, which is inside. And that's my answer. Now you'll notice the difference between, how come I had to make a table in step 4? I know that's always very confusing. What is 0? My b is 0. If you look back to example 1, b was 0. When b is 0, you need to make a table. All right, so let's do another one. This time we have all A, we have an A, B, and C. Open this up. And I'm going to actually, you get -3/2, it's a decimal. I like to actually convert it from a fraction to decimal. I think it's just a little bit easier. So really, I'm not going to do a lot of talking because you should be pretty familiar by this point between doing it in lesson 4.1 and now just adding inequalities, which is something you've seen many times so far this year. You just plug them in. And then my vertex is going to be -1.5. I'm just going to estimate where that's at. 1, 2, 3, 4, 5, 6. Just about here. Once again, draw your dashed vertical line through the point. It's our axis of symmetry. Now the next part, let's look at 3. 3, we need to talk about our y-intercept. It's -4. So I go up or down the y-axis. Negative means down. 1, 2, 3, 4. What's nice about this one, finally we had an example where it's not on the vertex. So here's my vertex, here's my y-intercept. From here, you see it's 1.5 spaces to the right of the dotted line. To be symmetric, we have to put a point on the opposite side. So we want to do 1.5 to the other side. And then it's a dashed parabola. So for once, we actually don't need the table. So we put n/a, not applicable for this one. We don't actually need it because we already have those 2 points. Now I can still test 0, 0, right? If I plot 0, 0, you're going to see that it lies inside. So let's do our test point. And I'm actually just going to write the end of the test because I hope by this point you guys are comfortable with the fact of not having to see the work. It in fact is a true statement, so I shade where it's at, which is inside. Because it's true. It lies inside the shape, inside the parabola. All right, so we have one last example here. y less than or equal to x squared plus 2x minus 3. So hopefully, like I said, you might want to pause the video and actually try it yourself, because it's a review from 4.1 and we already know how to graph inequalities from previous lessons. So, like I said, I'm not going to do too much talking about the problem. This opens up again. 2 is the vertex. So -1 for x. Y, we simply plug it back in to the original. So you get -1, -4 is the first point. So -1, 1, 2, 3, 4. Don't forget, you draw your vertical dashed line, your axis of symmetry line through it. And now step 3, we use our y-intercept, which is c, -3. And once again, the y-intercept goes up or down the y-axis. Y-intercept is -3, so you go down 3. Now you'll notice I have 2 points, and I'm going to use my line of symmetry to be able to do the third point. And I always look at the line of symmetry. You want to make sure you know which direction to go. So here's my dotted line. I have 1 point to the right of it, so we want 1 point to the left. Now, obviously, you won't need to use a table because you see I have enough points to help me out here. And when I draw the points, you see it's less than or equal to, so it's a solid line, solid parabola. Now, step 4, we could say non-applicable because that would be the table line. We don't need a table because we had enough information. Now, to test a point, next time again, we could actually use 0, 0 because it's not on a line. Remember example 1, we couldn't use 0, 0 because it's part of the graph, but we can. So step 5, we're going to test 0, 0. Back into the original, and like I said, like before, I'm not going to show the work. Make sure you could get the same inequality and how it checks that out as me. Get 0 less than or equal to -3. And as we all know, 0 is not less than or equal to -3, so it's false. So we'll put a little x. So if it was true, where would you shade? 0, 0 lies inside the parabola. So if it was true, we'd shade inside, but it's false. So you do the opposite. So in this case, we shade outside. So remember, it doesn't matter, like it's not like true is always inside and false is always outside. It's dependent on the point you pick where it's located. If it's true, you shade where that point's located. If it's false, you shade the other one. That's it. There's our parabola. Now, that's it for the lesson. Here's your homework. Do the problem of the day. Make sure I guess we sort of already did it sort of together, but go back in your notes to see the 5 steps we did in 4.1, and then graph the following inequalities.